Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the channel. Make sure you like this video. Go ahead and hit the button. All right, and also share this video with at least one other person. And also drop a comment. You know what I'm saying? If something I say makes sense or doesn't make sense, whatever. Like, drop a comment, ask a question, whatever. Put the, let's fill the comments up. What are we doing today? We're factoring out a GCF. What does GCF stand for? Greatest common factor. Greatest common factor. All right. Now, this is a different type of problem, right? This is atypical, right? But this is a problem that you need to know how to factor, this type of expression. Most examples that you'll see in an Algebra 1 class or even an Algebra 2 class where you have to factor, your GCF or your greatest common factor will be a single monomial, right? It might have a coefficient, it's going to have a coefficient other than 1, might have some variables in there, but sometimes your GCF will be a binomial, right? Like we're going to have here, and I'm going to explain that to you. Sometimes your GCF might be a trinomial, right? That's even more rare, but sometimes your GCF will be a binomial, right? So you got to look at each term. Now this is a binomial, this whole expression, because this is one term and this is another term, all right? Separated by the plus sign, right? The minus sign and the minus sign inside the parentheses aren't really relevant to determining whether this is a binomial, trinomial, or what have you, right? So this is one term, this is another term. So then you look at each term and you say, okay, what do they have in common? I see a y minus 2 right here, and I see a y minus 2 right here. The coefficients are 4 and 3. 4 and 3 are what we call co-prime, or relative, also known as relatively prime, meaning their greatest common factor is positive 1, right? So the 4 and the 3, when we talk about what the GCF is, the 4 and the 3 aren't relevant really because their GCF is just 1, and 1 don't really change nothing, right? But you got a y minus 2 here squared and a y minus 2 to the first power. So what do? When we have an expression, right, that's the same, the GCF consists of the expression that has the smaller exponent. The smaller exponent, right? So this 1 is less than 2. So that means our GCF is going to be y minus 2 to the first power, which is also just y minus 2, right? Just y minus 2. That's our GCF. So when we're trying to factor something and we need to identify what the greatest common factor is or the GCF is, I suggest we just write it down, but you look and see what they have in common. What do the terms have in common? I got a y minus 2 right here to the second power and a y minus 2 right here to the first power, right? All right, now, how do I factor this? So what I'm going to do is, because I have my GCF is a binomial expression, I'm going to use brackets. That's just something I picked up on. It's something I just started doing, and it just kind of makes more sense for me. So I'm going to write y minus 2, the brackets. Now, what's going to go inside the brackets? What goes inside the brackets is the quotients when I divide the first term by the GCF, and then I divide the second term by the GCF. Now, if I divide this whole term by y minus 2, I'm going to end up with this. 4 times y minus 2 to the first power. But do I need to write that 1 for the exponent? No, I don't. When 1 is your exponent, you don't need to write it. You need to understand that it's there, but you don't necessarily need to write it. Now, then I go to the second term and I divide that by the GCF. 3 times the quantity y minus 2 divided by y minus 2 leaves me with just 3, because y minus 2 divided by y minus 2 is equal to 1, because you're dividing something by itself, right? You're dividing something by itself, just like if you divide 5 by 5. 5 divided by 5 is 1. 98 divided by 98 is 1. X plus 4 divided by x plus 4 is 1. Whenever you divide something by itself, the quotient is always 1. So this is going to be just 3. Why just 3? Because 3 is what's left. If this divided by this becomes just 1, now you're left with 3 times 1, which is just 3. All right? Now, you could just leave it like this, but what I would do is clean the problem up a little bit. So I would simplify this. I would distribute the 4 to y minus 2. You do not multiply the 4 by 3. You do not do that. Do not make that mistake, because 4 gets multiplied by what's inside the parentheses that it is adjacent to. This binomial that 4 is adjacent to, because this says 4 times the quantity of y minus 2. This don't say 4 times 3. This says this expression plus 3. So you don't multiply 4 times 3, because the expression does not tell you that you should multiply 4 by 3. That ain't what it's saying. All right, so check this out. So we got 4y minus 8 plus 3. All right, and then outside we still got the y minus 2. So now I'm going to simplify this. I'm going to put this negative 8 and this 3 together. So we're going to end up with y minus 2 times 4y minus 5. Make sure you know how to add and subtract positive and negative integers. Negative 8 plus 3 is negative 5. All right, now look what I ended up with. Y minus 2, which was our GCF, times 4y minus 5. Where'd that come from? Negative 8 plus 3 is negative 5. Where'd the 4y come from? Came from here. Where did it come from before that? 4 times y. 4 times y and 4 times negative 2. That's where the 4y and the negative 8 came from. Whenever you're doing any type of math problem, do yourself a favor. Make sure that you know where every number came from, every variable came from, every plus sign, minus sign, division sign, multiplication sign, where every exponent came from. Make sure you know where everything came from as you try to make sense of the problems. All right, now this is going to be our final answer, but let me go back real quick, because I want to explain something, because I didn't really show you how we got this right here. 4 times the quantity y minus 2. And somebody watching this video might be wondering where that came from. Well, remember, when we find the GCF, y minus 2, you divide each term by the GCF. So it looks like this. 4 times the quantity y minus 2 squared divided by y minus 2. Now, this 4, right? There's no, now what you're not going to do is you're not going to do 4 divided by this negative 2. You're not going to do that, because negative 2 does not stand alone. It's part of this binomial. What you could do is think of it like this. Boom. Throw that binomial inside parentheses, right? Now we got a 4 and we got an invisible 1 coefficient. An invisible 1 coefficient. So because of that, 4 divided by 1 is just 4. Now, y minus 2 to the second power divided by y minus 2. This y minus 2 is really y minus 2 to the first power. So again, exponent rules, division property. Exponent rules, division property of exponents. When you divide expressions, terms, variables, numbers, whatever, you subtract the exponents, top minus bottom. What's 2 minus 1? That's 1. So that leaves you with y minus 2 to the first power. Y minus 2. Now, when my exponent is a 1, do I need to write it? No, I don't need to write it. So I'm left with 4 times the quantity y minus 2. That's where that came from. That's where that came from, in case anybody was wondering. That's where it came from. All right? So, and then the 3, we did this. Let me show you that real quick. So we took the second expression, 3 times the quantity y minus 2, divide that by the GCF, which is y minus 2, right? Treat that like that. This is the same exact thing. This binomial, same as that. That leaves you with just 1. 1 and 1, which equals 3 times 1 divided by 1, which is just 3. That's where this positive 3 came from. So always when you're doing any problem, make sure you know how to break it down and you know where every term came from. So our final answer was this. Y minus 2 times the quantity y minus 2 times the quantity 4y minus 5. All right? And so when you see problems where the GCF is actually a binomial, because usually most problems you're going to see, especially in Algebra 1, right? The GCF is going to be a monomial, what we call a monomial. Like mono, the prefix mono means 1, right? Prefix bi means 2. Tri means 3, right? But the GCF usually going to be a monomial. This is not a monomial, though. This is a binomial. You will encounter these sometimes, and you need to become comfortable with those. So when you see them, you don't, get all crazy and think, oh, I can't do this. It's too hard. I don't get it. You got to get familiar with these types of expressions. So that when also you following the same rules, it's just that the GCF is not a monomial. The GCF is a binomial. 1, 2, 1, 2, 1, 2, 1, 2, right? So just, you know what I'm saying? Don't stress yourself. Just, take your time and just follow the steps. But find problems like this and practice them. All right. And also, I want to say rest in peace to the late freedom fighter, revolutionary Assata Shakur, who just made transition last week. All right. So I got my Assata Shakur hoodie on. You know what I'm saying? So if you're not familiar with Assata Shakur, if you haven't read Assata Shakur's biography entitled Assata, if you haven't read the book written by her aunt, Inadmissible Evidence, which talks about her aunt, who was an attorney, her attorney, and how she worked to, defend Assata, her niece, and also other members of the Black Liberation Army, please familiarize yourself and just familiarize yourself with Assata Shakur. Do not get caught up in a lot of the negative propaganda about this sister, which is customary in the Western society. Freedom fighters always get a bad rep. So do your own research. Read her own words. You know what I'm saying? So read the autobiography of Assata, then get a copy of Inadmissible Evidence. Read that too. All right. And then have intelligent conversation about her. All right. And then in between doing that, practice factoring expressions that look like this. All right. I'll see you in the next video. Peace.